This video will show you examples to find different parts of trig graphs. Specifically, we're going to be looking at finding the midline, the amplitude, and the period. The first question you'll often need to ask yourself when looking at a trig graph is this sine or is this cosine? There's actually a really easy way to figure it out. If you look at the y-axis in the graphs, and then you find the intercept of at the y-axis. If your intercept is at a maximum, then it's cosine. If your intercept is at the midline, then it's sine. In this particular example, the intercept is right at the origin, but it's really only special in that it is at the midline. Since you'll need to find the midline sometimes to know if it's sine or cosine, let's talk about finding that first. The midline, remember, is the horizontal line, in this way, horizontal line that divides the graph in half. So in this graph up at the top right, we have our original or parent function where we saw the midline is just the x-axis. There is an equal distance above and below the graph. Let's look at the top left now. Here the midline's been changed. We can now see that the maximum is up at 2 and the minimum is down at 0, thinking of the range of the graph. So the midline is actually here at positive 1. So this graph has a midline of positive 1. Additionally, we now know it is a sine curve because we can see that the y-intercept is at that midline of positive 1. Let's jump down here now to the bottom right. Again, the midline has been changed. We see our maximum at positive 3 and our minimum down at positive 1. Well, the number between 3 and 1, that's 2. So our midline is a positive 2. We can also notice that this is a sine curve because our y-intercept is at that midline at positive 2. All right, let's do the last example. Bottom left. Now we see our max at negative 1 and our min at negative 3. So the middle there is going to be negative 2. So our midline here is negative 2. We can also notice that our y-intercept is at a maximum. So this is our only cosine example. Another feature of a trig graph you're going to need to find is the amplitude. Again, I've put the parent sine curve up in the top right. And if you remember from class, we learned that the amplitude is 1 on the parent sine and the parent cosine. We had two ways of doing that. It's either the height above the midline, which is 0, or you can find this total distance from the max to the min, which is 2, and then divide that in half, which is still 1. So we still have an amplitude of 1. These other graphs show changed amplitudes. So let's look at this large one on the left. This is probably the easiest one to see. So we'll start by identifying the midlines here at 0. Our max was 2, our min was negative 2, so the middle was 0. Now if I use the definition of height above the midline, well, I know that it's 2, so my amplitude is going to be 2. But if I instead decide to find the total distance and divide by 2, I could do that as well. So I'll start at the min. I have 1, 2, 3, 4. So my distance is 4, which I then have to divide in half, which still comes out to 2. So either way, my amplitude is 2. And just for fun, I will tell you as well that this is the sine because we cross the y at the midline. All right. This middle graph is a little bit more difficult to read, but you're going to have to trust me that this goes all the way up to 3, and then the min is down here at negative 3. Now when the midline is 0, the amplitude is actually really easy to find. It's always just going to be that maximum. So the amplitude here is also a 3. it's also sine because we have that intersection at the midline. All right, our last example is going to be a little more difficult. So let's look at the bottom right. Now, our max is at 1, and our min is -3. So our midline here is actually going to be at -1. That's what cuts the graph in half. So my amplitude is going to be 2, because my max is 2 above the midline, 1, 2. Similarly, my min is 1, 2 below the midline. If I wanted to find the total distance, it would be 4 divided by 2, so that is still 2. So our amplitude here is 2. Also, this is cosine, because our y-intercept is a maximum point. The last feature we're going to need to look at is the period. If you remember from class, we know that the parent cosine, which is at the top, parent, and then the parent sine, both have a period of 2 pi. So let's compare the shapes. Cosine starts at a max at the y-axis, goes down to a min halfway through the period at pi, then comes back up to a max, and that's where the period ends. This is one period. This blue that I have outlined is just one period. Sine shape is a little bit different. Sine starts in a midpoint, goes up to a max, down back to the midline halfway through, down to a min, and then back to a max to end the period. So sine shape looks more like this, and cosine shape looks more like this. Now when you string them together, they look exactly the same. But it's useful to think of sine as more of an S and cosine as more of a U. It'll help us find the period. So I've put 2 examples on the left, and they actually both happen to be cosine. So we're going to be focusing on the cosine over here. So this top one, we start at a max, we go down to a min, and back up to a max. We know that's the length of one period. So our period here is pi. It is smaller than the parent function. If you look below, we start at a max, we go down to a min, back up to a max, and we're about halfway to pi, so that's going to be pi over 2. So our period here is pi over 2. Those were both cosine. Now if I was looking for a sine, I would start at the midline, trace up to a max, down to a min, and then as soon as I hit a midline again, that's when I know I would have one period. So for homework, please try these 2 problems. Identify if they are sine or cosine, find the midline, find the amplitude, and find the period. Good luck.